Hey, welcome to Build&AI. I'm Nia, your AI learning guide. Let's get into it.
Welcome to the Explainer. Honestly, I'm super thrilled you're here. If you're ready to master the art of writing literally rock-solid code and getting it live on the internet, without breaking a sweat, well, you're in exactly the right place. Today, we're totally transforming the way you think about code reliability and modern deployment. We're going on a journey, right from the cozy safety of your local editor all the way out to a global cloud network. It's going to be fast, highly practical, and for sure, it's going to give you absolute confidence in your workflow. Let's get into it.
Now be honest for a second. Have you ever made a tiny, kind of seemingly innocent tweak to your code, only to find out, usually hours later, that it silently broke an entirely different part of your app? Yeah, we've all been there. And there's really nothing worse than that sudden wave of dread, right? Especially when it leads to a 3 a.m. production crash. But hey, here's the good news. Automated testing and modern serverless deployments, they're absolute developer superpowers. They're literally the cure to that 3 a.m. panic. By the end of this explainer, you're going to understand exactly how to build a safety net so strong you'll honestly never fear a refactor again.
Okay, so let's look at exactly how we're going to do this. Here's our timeline for today. First, we'll establish the front-end testing safety net. Second, we're diving into pure functions and Vitest. Third, we'll tackle mocking APIs for really reliable tests. And finally, we're going to take all that beautifully tested code and go live with Vercel. All right, starting right off with Section 1, the front-end testing safety net. You see, in any professional environment, automated testing is your ultimate safety net. Because as your code base grows, manually clicking around your app to verify every little thing, that's just completely impossible. Tests give you the absolute freedom to refactor, knowing that if you break core logic, your suite is going to catch it instantly. To build that net, we have to understand the stark difference between pure and impure functions. Now, pure functions, they are the holy grail of software testing. Why? Because they're completely predictable. Give a pure function the same input, and it will always, literally 100% of the time, give you the exact same output. It doesn't modify external variables, it doesn't talk to the internet, and it doesn't touch the DOM. But impure functions, they are chaotic. They manipulate the DOM, rely on external state, and trigger side effects. Testing them is an absolute nightmare because you have to recreate the entire surrounding environment just to see if they work. So the secret here is to separate your core logic into pure functions as much as humanly possible.
So what should you actually be spending your valuable time testing? Well, focus your energy right here. Test your core business logic, like, say, calculating discounts. Test your API data transformations, when you're turning messy server data into clean UI data. And definitely test your input validation so bad data doesn't crash your app. But take a close look at that last point. Please, do not waste your time testing third-party libraries like React or Vue, and definitely don't test raw DOM changes. Just assume the creators of those libraries have already tested them. You need to focus strictly on the logic that you actually wrote.
Okay, moving right along to Section 2, pure functions and Vitest. So, to test those pure functions, we use a ridiculously fast modern framework called Vitest. It runs tests in parallel, supports modern module syntax right out of the box, and fits perfectly into your dev environment. And Vitest brilliantly illustrates what we call the rule of 3 for structuring tests. Listen, every single good test follows this exact pattern. First, you arrange. You prepare your input data. Second, you act. You actually execute the function you're testing. And third, you assert. You verify the result matches what you expected. Arrange, act, assert. If you memorize this simple mental hook, I promise you'll never stare at a blank screen wondering how to write a unit test again.
Right, so once you've arranged and acted, you've got to assert. And this right here is your visual cheat sheet for Vitest matchers. Notice just how readable this syntax is. It honestly reads like plain English. You use .toBe to check exact equality for primitive values, like numbers or strings. But if you've got a complex object or an array, you'll use .toEqual for deep equality. That basically means it checks the actual contents, not just the memory reference. You can check if things are truthy or if a string contains a specific word. It's just incredibly intuitive once you get the hang of it.
Which brings us right into Section 3, mocking APIs for reliable tests.
Here's the thing. When your code talks to the outside world, like, say, fetching data from an API, you run the huge risk of creating flaky tests. And a flaky test is the worst. It passes sometimes, but then fails other times just because the Wi-Fi dropped or a third-party API went down. It totally destroys your trust in your test suite. To fix this, we use mocking. Mocking simply means replacing a real, unpredictable dependency with a fake, highly controlled version that you completely dictate. So instead of reaching out to the actual internet, your mock intercepts the call and immediately returns a predefined response. You're effectively stripping away all the unreliability of the external world right out of your test suite.
And the benefits of this are stark and immediate. I mean, why mock fetch? Well, first, it's incredibly fast. There's literally zero network latency. So tests that used to take seconds now take milliseconds. Second, it's completely reliable. No more random, flaky failures wasting your time with false alarms. Third, it's totally isolated. If the external API goes down, who cares? Your tests still pass because your core logic is still sound. And finally, it's free. You aren't burning through real API tokens or paying for usage every single time your automated tests run.
Now, I know what you might be thinking. Wait, if I'm just faking the response, aren't I just testing the fake? But here is the crucial point. You are not just testing the mock. Actually, scratch that. The mock only replaces that final trip across the internet. Your test is still rigorously verifying the actual mechanics of your code. It's verifying that your function calls the exact correct URL, that it uses the right HTTP method, like post instead of get, attaches the proper authorization headers, and correctly formats the JSON body. If you accidentally rename a variable in your request, your test is absolutely still going to fail and catch that bug.
And that brings us to our final stage, Section 4, going live with Vercel.
Okay, so we built our app, we've written super reliable tests with Vitest, and we've mocked our APIs. Our code is rock solid. Now, it's time for the cloud. To understand modern deployment, you really have to grasp this major shift. Think of traditional servers kind of like leasing an apartment. You pay for it 24/7, 365 days a year, whether you're actually sitting in the apartment or not. It's a constant, unyielding cost. Vercel, however, uses the serverless model. Think of this more like renting a hotel room for just the 5 minutes you need to take a shower. Your code only activates when a user actually makes a request. It wakes up, serves the user, and then immediately shuts back down. If nobody visits your app at 4 a.m., you pay absolutely nothing. Zero idle cost. It is a brilliant, highly efficient way to host.
Honestly, Vercel is basically a platform of automated superpowers. It removes all the heavy lifting and friction of traditional back-end operations. Just look at what it does automatically for you. It distributes your static files on a global content delivery network, meaning your site loads instantly whether your user is in Tokyo or Toronto. It automatically detects any code in your /API folder and converts it right into those highly efficient serverless functions we just talked about. It gives you automatic HTTPS, so no more wrestling with SSL certificates. And crucially, it handles your sensitive environment variables securely.
But the real magic? It's how incredibly fast this all happens. Let's just walk through this timeline. At 0 seconds, you type git push in your terminal to send your code to GitHub. That's literally all you do. At 5 seconds, a Vercel webhook automatically intercepts that push. By 30 seconds, Vercel is quietly building your project in the background and securely injecting your API keys. And in under 60 seconds, your fully tested application is live on a secure public URL for the whole world to see. From a single terminal command to global distribution in under a minute. It's just staggering.
But, with great power comes great responsibility. Listen to me carefully here. Never, under any circumstances, push your .env file to GitHub. That file contains your secret API keys. If you accidentally commit it to a public repository, bots scraping GitHub will steal your keys in seconds and run up massive bills on your account. Vercel securely manages these keys in their dashboard precisely so you don't have to keep them in your code. If you ever make this mistake, drop everything, regenerate your key at the source immediately, and delete that repository. Security is paramount here.
Which leads us perfectly to our final thought. You've mastered pure functions, conquered automated testing, and deployed a globally available serverless application. But consider this. Once your app is live, every single visitor is triggering your code and consuming your API quotas. So, I'm going to leave you with this question to ponder. How will you protect your newly public serverless functions from malicious bots or runaway traffic? That challenge opens up the completely fascinating world of rate limiting and authentication, and I highly encourage you to explore that next. Thanks so much for hanging out with me for this explainer. Keep building securely, and I'll catch you next time.
And that's a wrap for today. If this lesson was helpful, go ahead and hit that subscribe button so you never miss a new episode. We drop 3 new lessons every single week, all designed to help you learn, build, and launch with AI. Share this with someone who's on the same journey, and I will see you in the next one.